definition of a polyhedron. Polyhedron is a solid bounded by polygons. I think I mentioned this a little bit when we did surface area. Okay, so if it sounds familiar, then that's why. Talk about it during surface area. So, based on the solids shown below, which ones would you say are the polyhedrons? On the left, these right here. So all of these are polyhedrons. See, every face is a polygon. Okay, these are solids, which you can still find the volume of those. These are not polyhedrons because they're like rounded and curved. Okay, so let's talk about parts of the polyhedron. We've got faces, edges, and vertices. So the faces are going to be the regions that bound the polyhedron. So the faces are going to be like the polygons. Rectangles, triangles, squares. The edges are going to be line segments. Right? That's where two faces intersect. So it's like having two planes that intersect. And then vertex, you guys should know what that is already. Vertex is where three or more edges meet. So it's just a point. All right, so you got that is a face. Okay, you got actually how many faces? Let's count them out. How many faces are on this one? 6 faces. Okay. The edges, remember the edges go from just where two faces meet. Okay, so you have a ton of edges. Okay, go on and on and on. How many edges are there? How many? 12? Sure. And then vertices. How many vertices are there? There. How many? Okay, so if I just give you a polygon, you're going to tell me how many faces, edges, vertices there are. Okay? Okay, based on all the faces, edges, and vertices of polyhedrons, they're related by a formula called Euler's theorem or Euler's theorem, however you want to say it. Everybody says it in so many different ways. Okay? And the formula goes like this. F plus B equals E plus 2. F plus B equals E plus 2. So how many faces, let's see if it works, how many faces are on this polyhedron right here? 5 faces. How many vertices? 5 again. How many edges? 8. Okay, so faces and vertices, 5 plus 5, does that equal 8 plus 2? Yes. Okay, it works for all of those. So I'm going to give you 2 out of the 3 and say how many faces are there if it has this many vertices and this many edges. Okay? And it could be large, weird, crazy numbers too. Okay? Alright. Alright, so let's talk about these names. Polyhedrons are named by the number of faces. Write that down. Polyhedrons are named by their number of faces. Now, you can have more than one name because I already taught you a bunch of other names for these. Okay, like pyramids, prisms, all that. But when I tell you to classify it by its polyhedron name, you gotta be able to tell me that too. Okay? So how many faces does that one have? 5. So what do you think the name of that one would be? Hexahedron. It's kind of like related to the polygons. Okay? Polygons are classified by how many edges it has or sides. Well, this is how many faces. So we're going to write it. Hexahedron. Okay? How many faces does that next one have? 6. So what would that one be? Hexahedron. How many does that one have? 7. So this one is, you remember the 7 prefix? So one is always forgotten. Heptahedron. How about that one? So what's that name? Decahedron. Okay. And the last one? How many? 8. So therefore it's octahedron. Okay, so it just depends how many faces it has. Okay, so if I tell you to name it by that, so if I put a cube on there and I say classify it based on its polyhedron name, what would the cube be? Hexahedron, because that's 6 faces. Okay? Alright. Alright, so convex polyhedron is this one right here. Okay, so write your definition in your own words. What would be a good one? Person, what would be a good definition that you could say in your own words? It doesn't have to be all geometry, big terms. Yeah, in your own words. Polyhedron that's not closed. Well, that is closed, yeah. Space between. Write that down if that's what helps you remember it. What do you say, Alex? Have the space in between. Anybody got any other ideas? No, I'm not here. Jake? What did we call, how did we name it in our own words a concave polygon? Oh, shoot, sorry, I did it backwards.
That's what I was going to say.
So this one is not convex. Those are. So what do we say?
Oh, it's all. I mean,
Well, but that was close to. There you go. It doesn't take anywhere. So like right here, how about this? I take this. So I would just use that. This one doesn't cave in. That one doesn't cave in. All right, regular polyhedron. Regular polyhedron. What's a regular polygon? Mia? No, a regular polygon. You already know that one. Nope. What's a regular polygon? Equal angular and equal lateral, equal sides. Okay? For polygon. So what do you think a regular polyhedron is? All the faces are okay? So all of the faces need to be regular polygons, and yes, they also need to be congruent. Okay? So they're all going to have the same faces, all meeting the exact same weight. Okay, so here's a couple of examples of some regular polyhedrons. That one you're most familiar with. What's that one? A cube. Because all 6 faces are, and they are regular. What kind of shapes are those? Squares. Squares are regular, right? Okay, so the cube is a regular polyhedron. And then this one looks a little awkward, but all of the faces are the same. Okay? Regular polyhedrons are polyhedrons that have regular, they're made up of regular polygons. And they all got to be the exact same and meet the exact same way. Good? Are you guys good next one? Okay, so there's 5 special regular polyhedrons. You've got the tetrahedron, you've got the cube, okay, or hexahedron, you've got the octahedron, the dodecahedron, and the isosahedron. Okay, so did I put pictures of these for y'all? Just write them down, okay? These will kind of remember what it looks like. So the tetrahedron is this one right here, and it's actually above your head hanging from the ceiling. They're all tetrahedrons. They're what is called the tetrahedron type. A lot of you heard me say that before. So in this case, this one has 1, 2, 3, 4 faces. Okay? Tetrahedron is 4 faces, and then there are 4 regular triangles. Okay? Gotta be triangles though. You want to write on the note? 4 regular triangles. Okay? You know what the cube looks like? How many faces does that one have? 6. And then the octahedron is this one here. This one is made up of triangles. Okay? And of course, octa comes from 8, so that has 8 regular triangles. So I don't know if you also want to write that right below the name, 8 regular triangles. Okay? This one has 4 regular triangles. This one has 6 regular quadrilaterals, or you could say squares. Okay, and then the dodecahedron is, which one do y'all think? The bottom or the top one? That's the dodecahedron. What kind of regular polygons are those? There's 12 of them. What kind of regular polygons are those? Somebody said it. Say it louder. Pentagons. 12 regular pentagons. And the last one, the isosahedron. She studied these terms because everybody was forgetting this one. How many faces do you think it has? I'll let you stare at it for a little bit. 14 is incorrect. 20 is correct. our regular what? Triangle. So this has 20 regular triangles. Okay, so to make a regular polyhedron, it only kind of works with these shapes only. Okay, triangles, squares, and then that pentagon. Okay. All right, like a regular polyhedron. Be able to, if I ask you what an icosahedron is, be able to tell me. Okay, and what it's made up of. I ask what a regular polyhedron that is a dodecahedron. Tell me what it's made up of. What kind of regular nucleus. Okay, right versus oblique. Okay, because you might see some oblique. These aren't on your notes, so you just maybe want to take a mental note or write a little note at the very bottom or on the next page or somewhere on the side. But when it's a right prism or cone, okay, right prism or cone or cylinder, that means you have it's pretty much standing straight up and down. Okay, so this height right here is going to be perpendicular to the base at the top and the bottom. Okay, see this height here? That's perpendicular to this base. Okay? Since all the lateral edges are perpendicular to its bases, the axes of the cylinders and the cones are perpendicular to the base. Which is, this axis is also known as the height. Okay? This right here, all these lateral edges perpendicular. So I like to use the keyword standing perfectly straight up. Okay? Over here, these are oblique. You can see what happens to the figure, kind of at a slant. Okay? So when we use, or when we have to find the volume of these type of prisms, pyramids, cones, cylinders, we need to use the perpendicular height. So this height, this height, this height are the ones you're going to want to substitute into the volume formula. Okay? So it's at a slant. This right here is no longer your height that you want to use. You want to use the perpendicular height. Okay? This right here is no longer your height. When in fact over here it could be your height, right? So on the right prism and cones, the heights are usually how they are. As I think we use some of them in service area. You're mainly using the height with help. Okay, so that's slant. You make sure you use the perpendicular height. I don't know if you want to draw at least one of those and draw an arrow to this height and say use this H for volume. Because we're about to get into volume now. Right? So know the difference between an oblique figure and a right figure. Okay? You can use right prisms, cones, and cylinders, oblique prisms, cones, and cylinders. Any questions about oblique versus right? Alright? Okay, so what is volume? Volume is the number of cubic units contained in a polyhedron or a solid. It could be any solid. Okay, so the number of cubic units. Okay, so now we're going to do cubic units. What kind of exponent is that? What? A cube. Right. So like when we write that the area has 100 units squared, that's area. Now we're going to do units cubed. Okay, units cubed. Inches cubed, centimeters cubed, all of that. Originally, this is how it developed. A cube, that means all of these are 1, 1, 1. 1 times 1 times 1. You remember how to do volume from middle school? So 1 cubic unit. So how many of those little cubes fit into a solid? That's what volume is. Volume congruence. Volume congruence. All that is 2 figures what about the prism and the cylinder? So those are those two kind of tied together. These are on the formula chart. And it's capital B times A. Do you remember what capital B means from surface area? Area of the base. So remember I told you I'll highlight, and some of y'all started kind of picking up that strategy. Do it again. So here, this will be your capital B. Same thing over here. This will be your capital B. Okay? And they should be identical to the other one. If they're not, then it's not a prism or a cylinder. Okay? So write it down twice for both of those. So the rectangular prism and then the right prism / cylinder are the exact same. Okay? Now this is going to be your height, and it always goes from base to base, and they have to be perpendicular, just like I think I mentioned in surface area. This one is oblique, it's a little slanted, so this is going to be your height. This right here, they may give you that number, okay? And I bet you some of y'all are going to plug it in, but you're not supposed to. You need to use this one. They'll probably give you that much to make you do what? With that Greek theorem or trick. Alright? So that's for both of them, the prism and the cylinder. Okay? It's a repeat again on the other one. It says prism volume conjecture. The volume of the prism or cylinder is the length multiplied by the length. What goes in those two lengths? Not base. Area of the base. So area of the base. There it is right here. That goes in that one first length. Okay? And then height goes in that second length. Okay? Write it down anyway, though. Come on, you didn't write anything down. So you write those two down, and then those two lengths is what I just talked about. All right, let's do some examples. Okay, these are probably not on there. All right, so you guys should draw them. Okay, so scratch out that cube and draw that one. Scratch out that cube and draw that one. It's real easy to draw. Draw the hexagon first. So I'll show you. Hexagon. Draw that. And then just draw 1, 2, 3, 4 lines going to the right. Or diagonally, I should say. And then just connect them. All that. What's that thing called? A 3.46 centimeter. Awesome, right? All right. So capital B times A. Simple formula. What is capital B in this case, guys? Which is a quantum times parameter divided by 2, and then times the height. All right, so a quantum is 3.46. What's the perimeter, guys? 24 all over 2. What's the height of this prism? 8. All right, I like to simplify first. I know that the 2 and the 24 are going to reduce to what? 12. And now just punch this in your calculator. 3.46 times 12 times 8. And what do you get for the volume? So guess mine's around the 3 places. So 332 what? And this is centimeters cubed. Okay, pretty easy. Okay, do that one there. Yeah, scratch. I guess you could use the same picture, just scratch out all of them actually. These are completely different numbers. Scratch out all those numbers you have and then write those down. All right. Same formula, capital B times H. What's going to get plugged into capital B? Is it a Polyhedron times perimeter divided by 2? What is it? Is it a Polyhedron times perimeter divided by 2? So what is it? What? Okay, why are you saying numbers? Is it a Polyhedron times perimeter divided by 2? No. Okay, so what is it? Okay, sometimes divided by 2. Well, I will get it here, and I'm your 4. I don't know what. Yeah, no. Okay. Now, see how there's 2 H's now? What is this little H for? Height of the base. So, of what's the base? Height of the triangle, right? So, height of the triangle, this is height of the prism. What's the height of the prism? I know that one. That's a 3, so get that out of the way. What's the base and the height of the triangle? The base is not 7, y'all. What's the shape of the base? What kind of triangle? A right triangle. So let me draw that over here for y'all. Okay? So draw your right triangle off to the side. Everybody do that right now because you just gave me the wrong number. So what is this? 7? And then what else do we know? 4. So what's the base? 4. The base is 4. What's the height? Huh? Yeah, you put that right here. All right, so you put that right here in your calculator. Jake, what is it? You have a calculator? Just punch it in. Punch it like that. 7 squared minus 4 squared. 7 squared minus 4 squared. What did you say? Square root of what? Square root of 33? 29 minus 16 is 33. We'll just leave it like that. Okay? So square root of 33. Okay? It is some decimal because it's not a perfect square. That's okay. What happens to the 2? Let's do a fraction. We can add that reducer. Yes. So what is the factor 2? 2. Okay? If I told you to leave it in simplified radical form, what would your answer be? 6 radical 33. There's no pairs there. I'm reading 11. Right? Nothing there. So there's the volume of that. 6 radical 33. Anybody get the decimal? Anybody get that? Let me plug it in real quick. Please don't put the cube on the number, okay? Because then you just lose that volume up, and that's wrong. All right, last one. Last one, let's see your answer in terms of 5. Okay, scratch out that cylinder that you have and copy that one. What kind of cylinder is this? Starts with an O, oblique. Okay, so let's see, they already gave us the correct height. Don't forget, if they give us the slanted one, that edge, if they give us that edge, you might have to use that ring. There's not hard to think. Alright, so still same formula, capital B times H. What goes into capital B? Which is? Very good. I R squared. I, what's R? 2.5. And then the height? 8. Alright, this is easy. So even in terms of height. What's 2.5 squared?